Hello and welcome to the second module of the captivating course Blockchain for Finance Professionals. Let's jump to the second module, which is all about advanced blockchain concepts. Roughly, we have almost 8 topics in this module, and in this session, we'll talk about fundamentally what blocks are. So, we are starting the module 2, and the module 2 will be called as Blockchain Advanced Concepts. Here, we will be understanding a little bit of blocks and how blockchain can enable bit of technology, and especially in the financial industry, how it can quickly solve a lot of issues that we have seen in the earlier modules. So moving on to the first submodule. So the submodule 1 of module 2 is blocks. Let's understand what's a block. We have seen a bit of this block in the earlier sections. So the first question is still we have is how do blockchains work? Because it's a question that we need to answer now and then, because the concept that we need to understand is that how the blockchain is formed and how it enables the various characteristics that it brings in as a technology disruption. So how does it work? Primarily, what is a blockchain? As we have seen, a blockchain is a sequence of hash chained records. That means like you have seen one block getting linked to blocks, and it goes one top of the other and gets cuts off itself, and it's a kind of records, chain records. So you have n number of records, and in the thing like you can't change anything in the past. That means like what we understood is immutable. So what is the proceduring of adding blocks to blockchain? And we have seen an example of Bitcoin, how it gets added to blocks, and we have seen like it's like characterized by the size of the block and the faster the mining it happens. So it's kind of how it is done. That's the second question we need to ask. So what are the valid conditions for blocks? Are transaction valid? Do we need digital signatures, etc.? Or is it enforced by consensus? That also we understood, right? We need a 51% consensus at least for a Bitcoin kind of a mechanism. And finally, what is the procedure for deciding between alternative candidate blockchains? Like example, which is the right blockchain for the right solution? So we need to understand all these questions. So we'll see some answers in the forthcoming slides. So the first one is, what is building block? Let's understand what is a cryptographic hash functions. We have seen that a cryptographic hash function takes a bit string as an input. Like it can be a file. It doesn't have to be a Word file, or it can be any file. It has typically a fixed length output, because for any input you will know there's an output, and typically the output size is either 256 or 512 bits, and there is no way we can get collisions. And we have seen this bit in the Bitcoin simple concepts. So it is basically 110, 101, 001 kind of a thing. And the most of the people follow the SHA 256, SHA 512, SHA 3256, which is currently very popular. And RIPEM is one of the cryptographic mechanism or the standard that currently many people are using. So there is a real maximum input length. So input can be anything maximum, but actually it comes as a 256 or a 512 bits. So it's a very important characteristic that is used in blockchain. So let's understand what is a collision. That means like I have two different inputs, x and y. So that means like hash of x is equal to hash of y. That's a collision. But for a cryptographic hash function, it is collision resistant. That means it's impossible to find colliding impulse. For example, a black cat crosses the road and a black cat runs across the road. Or if you take a black cat crosses the road and a white cat crosses the road, it's all different. For every input, there is a unique output. That's the beauty of this. There's absolutely no collision. It's completely collision resistant. So why we need to understand collision resistant useful? It's because for every input x is equal to y, such that hash of x is equal to hash of y. Then we can use for any kind of a message digest. That means like a classic use case is a digital signature where it's unique to somebody and nobody can change without changing hash. That means like there is no collision in that. For electronic signatures or digital signatures, that is a uniqueness. There's a single identity, there's a single person, and there's a hash character of that, and no two people will have same hash. And once I know hash x, we can show hash of x, and we can have x star, but it won't have the same hash. So for every input x, there is a unique output y, and for every input x star, it will be y star. So that's the beauty of this, and biggest use case is digital signatures. So hash chains is basically, here I'm just trying to give you how the records are linked together. So every hash is linked to the previous record. That is what I'm trying to show you in this slide. Nothing more than that. So what's a hash chain? A hash chain is a series of records in which each record contains the hash of the previous record in the chain, and hash of all the current records contents. So hash gets converted to previous one, previous to previous, and finally previous. So linking records together, each record contains the hash of the previous record.
So that is the most important one. So why do we invest in this? Because we are using a cryptographic hash function like SHA-256. This means two inputs will have the same hash value, and it's a committed n records that is available. And for every n, it will be n-1, n-2, n-3, and so on. So that is very, very important. That's how blockchain uses one of the best technologies to interlink themselves. So how does it help in blockchain? Hash chains have the property that record every record, and it's a commitment to previous record. That means like one string is attached to the earlier record, it keeps attaching. So for an n record, you will have n+1, n+2. You have seen that record, right? It goes into the previous one. So once we accept every record, it shows us as the algorithmic progression like 1, 2, 3, and n-1. So why we need to use this? Because blockchain use hash chains as a component. And hash chains are also useful in other contexts because it's also helping you the arbitration, so that your change history cannot be changed always, it is like intact. That's how the relation between hash chains and blockchains is a very important concept. Because blockchain uses hash chains as a component, it's important for us to understand what is hash chain. Now that comes as a blockchain. So this is an example of a Bitcoin. You have a transaction 1, 12, 13 on the brown side in the diagram, and you have 3 blocks. So each block comes with a commitment to all the previous blocks on the transaction. So for H is a transaction that gets stored as a hash 10, then 10 goes as an input for hash 11, and input of hash 11 goes as an output for hash 12, and so on and so forth. So the essence is that each block in the chain commits to all the previous blocks and transactions. And I will try to explain what is nonce specifically to Bitcoin in the future slide. So the main core thing we need to understand is the hash of the previous block and each containing sequence of transaction and a nonce. So what is one of the validity conditions? What will the world accept as a next block? As this is decentralized, we don't have any trusted entity to decide what may be added to the blockchain. So we have to decide. The people in the ledger or people in the chain decide. For example, in Bitcoin, signatures are needed from moving one Bitcoin to another. BTC stands for Bitcoin from an account, and you can't leave a negative balance in account. And block must contain proof of work. We have seen what is proof of work and proof of stake. And if there is an additional block and it doesn't qualify the conditions, then it cannot be forming a valid block. So the valid block is actually enforced by consensus. Very, very important. So validity conditions is key because that decides the blockchain progression. What are fork chains? So blockchains are used in distributed systems. So you understand, right? Actually, distributed ledger it started. Blockchains are a kind of distributed systems. So it is possible for different parties in the system to have a disagreement. That's how it is, right? That's why they say like in Bitcoin, it's like 51% is agreement. So there is no trusted arbitration, right? That's one of the uniqueness. And any blockchain must deal with this. That means there are Alice and Bob. They no longer agree to the same state of the world because they don't agree on history. So here you have to come who is right. There can be several disagreement techniques to resolve disagreements. That's a beauty. Somebody comes with a better challenging algorithm on Bitcoin, he mines faster. So that's how like from earlier transaction which happened in home computers, now you need high-end speed computers and probably quantum computers in future. So fork chains are basically a part of chains that somebody else is using kind of to make sure that no two algorithms are same and they get an improvement in the blockchain. So what is important is we need to add new blocks to the chain. That is important. And any blockchain has to determine who can add blocks to the chain and how it's done. So two main ideas I will discuss is proof of work and permission blockchain. But I will not be discussing more on proof of storage and other things. But I will be more discussing on proof of work and how permission blockchain happens. So I just want you to do a big computation. Why proof of work is because it limits the rate of new blocks. It makes attempts to add invalid blocks to the chain expensive. That means a clear way to decide between competing chains when there is disagreement. The one with the most work wins. And not all blockchains use proof of work. That's very, very important. So it provides a clear way to decide between competing chains. And there is a disagreement. And the one with most work wins. And not all blockchains use proof of work. It's very important. So building block depends on how you use proof of work mechanism. That means like you need a disagreement algorithms in the blockchain that most of them accept. In case of Bitcoin, it's 51%. So that's kind of proof of work. And here you have a hash-based proof of work because you can find this challenge as 2 power 220. That's a kind of a limit, and you can typically find in such that it is like SHA-256 C/N less than L. That means like you can have a 2 power 36 probability of having a success, and when you succeed, only one takes me to have to check. That's like Adam Back's hash cash scheme. Understand this? You have 2 power 220 challenges. Out of that, if you use SHA-256, the expected kind of proof of work comes to as 2 power 36, which is like as a probability. And out of this, only one gets agreement, and that comes as a hash value to check for the new block. So you have seen this. You have transaction 11, transaction 12, transaction 13. And we have to choose this value on the yellow table. That's nonce 1, nonce 1, nonce 1. But you have different blocks. And it should be always less than L. So you have 3 blocks in the blockchain. The nonce is the first block to choose to force its hash value, which appears in the second block. But it should be less than L. So hope I'm making sense. The hash value should be always less than the nonce. And it should be concurrent with the second block. So that's how you get the algorithm done using SHA-256 protocols. So mainly what is proof of work? It actually solves some problems. We can resolve disagreements. As a financial consultant, you just need to understand this only one point. Blockchain to a certain extent works on proof of work mechanism. Proof of work here means solving the agreements, disagreements by using the best algorithmic method, using hash characterizations till that everybody's agreement and the chains should work. And second thing, it actually disqualifies the wrong block and protects it. That means like discourage people trying to add invalid blocks. That's how the entire Bitcoin thing has been designed. So why this agreement? Because I'm having a blockchain. As a third party, I can fork the chain and I can put my algorithm into chain. But if I do a wrongdoing of this blockchain, it will create issues. So that's the reason you need to have proof of work. It actually solves many problems, but some of the key problems is agreement, disagreement, and giving proof to that invalid blocks doesn't get added to the blockchain. So I hope I'm making sense here, and Bitcoin has cleared this design in a very decent way.
So that's all for this session. I hope you understood the very first session of the second module. In the next session, we will introduce with the blocks in advanced. Thank you. Hello, in this current session, we will know blocks in advanced level. So let's get started.
We also need to understand that proof of work resolves some of the problems, but it's little difficult in terms of cryptocurrencies, at least to use Bitcoin as an example. As I said earlier, there were a lot of things that can be solved using personal computer, but now more and more people have been forking Bitcoin algorithms and they have got best algorithms, and that's the reason now it's expensive and it actually needs special mining. So, and second thing is it's actually very slow. The transaction speed has come out very slow. And it's like you need to wait for every 6 blocks, at least an hour, to be sure of a transaction, at least in Bitcoin. So that's one of the reasons why proof of work is kind of getting a bit legacy in blockchain. So that means like to come away or to get away with the block proof of work, that's why we have this permission blockchain, or what we call as private blockchain, where it's an alternative to block proof of work. And the second thing is you have some entrusted entities who can work together to add records to the blockchain. So if you know who are the trustees, for example, you have 5 trustees, and if you have 3 people who are in favor of adding a block, then block is added. That means out of 5, you just need a 3 on 5 signatures. And resolution also is very easy, right? Because you know who are the competing blocks, and you will also know how the votes have been given. So that's the reason permission blockchains are actually gaining importance in the enterprise world. So this is a typical ledger that you have seen, right? It's been existing for so many things. So ledger can be a simple record book, it can be a databases, it can be with records. There are so many ledgers, right? Every market has its ledger. For example, an inventory ledger, a transaction ledger, banking ledger, so on and so forth, right? And every organization will have its own ledger. So you have multiple ledgers, right? What are the disadvantages? Problems, faults, diverging. So every Charlie, Alice, Bob, everybody has their own ledger, right? And that's the reason there will be a lot of defaults. So that's why you have blockchain, right? This is from Geneva conference. Like it has one ledger, whether we have Franz or Bob or Charlie or Dave or Eve, doesn't matter. It has one trusted common ledger, and it's implemented by a centralized intermediary. That means like the process is decentralized, but it is actually a single point of contact. It's single ledger for all parties, and it doesn't have replication, and it produces collaboratively. And why it is safe? Because it has a cryptographic protection and it has a distribution validation. Who is distributing what. So blockchain provides one virtual ledger. It creates single ledger for all parties. It's replicated and produced collaboratively. It helps in trusted form, and it unifies actually, and it's replicated and collaborated, produced with a good fashion. So for characterization of blockchain, on the right hand corner I see cryptography. Why cryptography? We have understood hash. We have understood SHA-256. So why cryptography? Because it brings in the integrity of ledger. It shows the authenticity of transaction. It increases the privacy of transaction, and it helps in identity of participants. Second, left hand side, it's a replicated ledger because it's ultimately one ledger. It's immutable. It has multiple storage of records, and it's past distributed and replicated. So you can't actually tamper the records. Third is consensus. You have a decentralized pool, you have a shared control, and you have a transaction validity which is exactly available. Now let's understand what's the business logic. You have a logic embedded in the ledger. You have execution that comes in the fair transaction way, and you can do anything, any use case, from simple altcoins, your Ethereum, to you can enforce smart contracts, right? So these are the four different elements that actually characterizes blockchain. If somebody asks key characteristic, it's cryptography, it's replicated ledger, it comes as a consensus, it comes with a business logic. Let's understand what is meant by state machine. But just this is in a high level that I am providing here. State machine is basically a transformation that happens for a functionality from a state S to the state S / to generate a response. This is something like your functional theory, or probably game theory, or probably set theory. It's a combination of this. It's actually done by a Boolean algebra, right? If it's true, it goes as a true. So it comes as a functionality. It transforms from one state to another state, and it comes with a validation condition stating like, it should be validated with a probability of P, and if it is true, it gets validated. So it's a state machine. So why it comes? Because I'm talking of a blockchain state machine. That means like there is only one append only log. Every operation appends a block of a valid transaction to the log. So S to S state will have increased 2 blocks to 3 blocks. That's all. Nothing else. So it's only append only log and keeps adding the blocks. And the second thing is each log content is verifiable from the most recent element. And each log entries is coming from a hash chain. We have seen what is hash chain, right? This is in reference to Geneva Conference 2017. So that means the hash of transaction 1, transaction 2 goes on hash T1, T-1, output to T, the transaction T. So blockchain state machine is like you append the block for a valid transaction from a state S to state S dash and keeps adding the blocks, and it's actually verifiable from the most recent element. So understand this, it's trade transaction S to S / S star. It appends only the block. It verifies the validated content which is in the log, and it's a part of hash chain. So that's how you have blockchain state machine. So I'm giving an example of Bitcoin state machine. See, these are just for examples, okay? This is just for information, because as a blockchain finance professional, you should understand the technology behind these transactions. So here, Bitcoins are unforgeable bit strings. It's actually mined by the protocol itself. It actually comes with the digital key signatures. That's what you see. That helps in transfer and owning of Bitcoins. And every transfer of a Bitcoin is kind of changing. And one flow from another one, it's actually signed with the current owner. And validation of history of transaction can be easily seen. Because owners are pseudonymous. You don't need to know. And digital signatures, they play a part of the transfer coins, which is a Bitcoin. And you can actually do a validated history of the past transaction. That is very, very important. So let's end this here. Next, we will discuss about the various consensus mechanism of blockchain. Thank you. Hello and welcome to this session. In this session, we will understand how do we mine the blockchain. So let's move on towards the topic. So let's understand a bit of section 2 in consensus. So we have seen state machine. We understood what is a block, how hash characterization helps in a block. Now we will move to bit of second is what is called as consensus. So we have seen this. It comes through what we call it as a Byzantine agreement, which is existing in the war field. That's how you have seen, right? In a permission blockchain, you know the actors. And similarly in the consensus, you have to need a majority of the vote to make sure that you come into the consensus, So there are various forms of consensus. Every blockchain comes with a different consensus. Here I'm showing you what do you mean by distributed consensus, and it comes with an agreement where all honest parties have the same value. And third, you can have validity which for every V will be accepted for every output. And third, it can be terminated. So there is another example called Me94, which is actually a strong consensus. Again, it's a part of the all tolerated consensus mechanism, which I just want to mention it here because it's one of the required. You just have to understand this, or you just have to know this. That's all. So actually there are three parts to this. The model is you need to set up a way that you can come to a consensus, and what are the assumptions behind this consensus. So channels is like point to point, right? You can see the red dots on the right hand side. You have 1, 2, 3, 4, 5, 6. It's almost like a matrix where you have a point to point, and it comes with the communications, right? So you have a network protocol communication running between one point to another point, and it's a synchronous communication. As you have seen in network communication, this is what we call it as a mesh network. So it's kind of rushing and it's unbounded, right? Because that's the computational power. So it's unbounded, it goes on a polynomial way. It gets authenticated using cryptography authentication in very highly secure environment. So what is basically a model is you should have a channel, you should have a network communication protocol which is synchronous, and you should have a high-end computational power, which is very, very required. So the best part was it started with Nakamoto consensus, which is used by Bitcoin, and basically you see like a nodes prepare blocks, kind of list of transactions, and all valid transactions are stored. And so as I said, it actually solves a lottery race. So you don't know who is a winner and a loser or leader. The winner operation is execution only. The power or the compute power and the algorithmic power actually makes a new Bitcoin generation. But the basic thing is it comes with a consensus, like how fast the consensus can happen between the miners and how long the chain is validated. And sometimes you see longest chain wins. So typically Nakamoto consensus is like a lottery race, but it comes with two principles: valid transactions and listing all transactions with valid proof. So that is kind of what is meant by Nakamoto transactions or Nakamoto transaction consensus, which is used in Bitcoin. So this is permissionless, right? We have seen, anyway, I'll come back to permission. So it actually survives censorship and suppression, no central entity. So what Nakamoto produced was proof of work. So original intent was one vote per CPU, but that is not happening now. You might have read, maybe as an interest, you can always look at what is hash power, what is Bitcoin mining, though I mentioned few, but it's a growing subject, and they're giving huge incentives to get one Bitcoin mining. And currently from a single laptop or a single desktop, it is now requiring 1000 megawatts. That's very, very electricity consuming. And stability is also increasing. What do you mean by stability? Is a trade-off between dissemination of a new block. And so as I said, you can create 6 blocks in an hour, and that means you need to wait. A trade-off is actually between 10 to 20 seconds in a new block, but it actually depends on the mining rate also, and you might not even know that the decisions are final. So decentralized but permissionless. So it is kind of understood in a detailed way, but we need to wait and watch. Decentralized deployment, Bitcoin is one, but there are thousands and thousands of altcoins and blockchain. So Ethereum is the first digital currency with the purpose of smart contract. I did explain in the earlier modules. And now you have this POET consensus with Sawtooth, which is Hyperledger. So basically, what is POET program is basically it comes with a trusted execution environment. It reduces amount of time. It creates an attested proof of elapsed time, and it's like a Bitcoin protocol. So primarily, you need to at least understand 3. Bitcoin, it comes as a proof of work. Ethereum typically runs as a proof of work, but it also creates a digital currency with another digital currency, but it has more of a smart contract execution as a use case. And finally, you have Hyperledger Sawtooth Ledger, which is kind of goes with the POET program. So I'm just going to the consortium consensus, which is Hyperledger. So there are designated set of homogeneous validator nodes. So you see on the right hand side, right, green color, blue color. Basically, there is agreement which is already defined. And there are quorums, that means it's easy to find out the faulty. So all the transaction goes to the consensus node. So all this all the green. And consensus validate transaction and decides and disseminate results. So you have a lot of transaction, the small one, big one, and it kinds of goes into transaction mechanism and it disseminates. So all the blue ones that you see are the transactions, and once it is approved, you see a tick mark. And once you tick mark, then it's kind of consensus and the results are disseminated. That's the important thing. But let's see what is meant by permission. So Hyperledger is a kind of a permission ledger. So what happens is, in this, there is a central entity which controls your group membership, and a group can be decided by inline by protocol itself, and there can be changes in the protocol, and it's open source. That's one thing, because this is one of the understood problem in distributed computing, and many systems also provide a crash tolerant consensus, and this permission consensus is growing, but the scalability and communication efficiency has to be mapped. Just for information, there are a lot of communications consortiums. So this is one of the permission ones, but primarily it is led by Hyperledger. As I said, some of the under development are Hyperledger. There is other ones like Iroha, Chain, all in existing now. Some of them are coming with use cases. Then you have Honey Badger BFT. That's again not much use cases with that, but you see some other examples like from Lisbon and John Hopkins University. So these are some of the consortium consensus under development. So you see, it's a kind of a matrix, greater than 20 nodes on the x-axis and greater than 1000 nodes, and you also see a performance. So the main critical issue is the node scalability versus performance in terms of latency. And third thing is transaction speed. So you need to understand three things. One is node scalability. Second is transaction speed and latency. And how are the protocol efficiency? Those are the things which is kind of required in a consensus mechanism.
So that's it. I hope you have a basic idea on mining. In the next session, we will dive into databases, which is mainly distributed databases. Thank you. Hello and welcome to this session. In this session, we will understand how do we mine the blockchain. So let's move on towards the topic. So we have understood typically what's the important parameters for a proof of work. Let's also understand what are the transaction validity. So as we please recall the validation that we said, like for every operation, that means like you have for status for performing an operation O. So when constructing a block, the node actually validates all the contained transactions, and it also decides on which to order within the block. Understand this? Constructing a block means all valid transactions. So if the protocol is not actually useful, it actually detects the unuseful block which is not correct, and it actually cannot be attached to the new block. So very, very important is when a new block is propagated, all nodes must validate the block and its transaction. For an example, if you say for Bitcoin, it has to actually verify all the digital signatures and make sure that there is no double spending. We have seen what is double spending, and it actually shows that the coins are not spent. And it's more complex and costly for Ethereum because it actually runs on the smart contract node. So it's bit of transaction. So validation can be expensive, but you have seen like now a lot of protocols comes in, which is kind of transaction speeds are becoming very, very faster at a fraction of cost. Well, we have seen this, but just only one thing in the slide. You just need to understand the Byzantine consensus. It's basically like every node should verify. There should be an agreement. And that means like no two correct nodes should differently. And every termination also should have correct node only. That's the only important thing, and nothing else as a BFT. So let's understand a bit of private validation versus public validation. So far, is everything on blockchain? Where is privacy? So that's why we use cryptography, and it gives you a verifiable transaction. But in Bitcoin, it's actually a digital signature which is kind of private. But in other examples, Zero Cash and Hawk, it actually checks for the valid proof. But if it has to be completely private, it requires some additional consumption, which exists between the permissioned blockchain, which is typically of the Hyperledger. There is a way that already trusted parties are entrusted, and who are actually participating in the validation. That's kind of a private state. Many things, like you may ask one question. You have seen Bitcoin, you have seen blockchain, you have seen permissionless, private, public. But then where is security? Security and privacy is already existing. It's a part of blockchain. So there is a transactional privacy because you have cryptographic tools. There is a contractual privacy because it's actually again computation which is with encrypted data. There's an accountability and non-repudiation because your kind of identity is masked. And at the same time, in a private blockchain, who is the identity. It's auditable, it is transparent. That's all we have seen. For any hash character which is as an input, there is an excellent output hash character which is completely different. That means like for any input, there is an output using hash which is completely different from other ones. And all of these need
high-end cryptographic protocols. So to a certain extent, it's secure. It also carries some privacy. So that means like we have seen the consensus to a certain extent. We have seen from permission blockchain how it is different from proof of work, how what are the critical characteristics that is required, and we have seen like it enables kind of security and privacy. Now let's move on to the section 3, which is called mining, because actually you see mining started with Bitcoin, and people are making money using mining. So what is mining? The byproduct of publishing the blockchain. So this is a race. It's a way that Bitcoins are created. Which Bitcoin? New Bitcoin. So as a result, miners get transaction fees plus also they get some rewards. It's a race to find confirming hash every 10 minutes. So you have to have cash, time, and electrical engineering skills. As I said earlier, Bitcoins used to get mined in a laptop or a desktop. Now you see you need 1000 megawatts for mining. It's incredibly competitive, high upfront investments, difficulty, and it requires specialized hardware. Earlier with simple laptop or desktop it used to get mined, but now you see like it's getting mined using chip, which is itself an investment for companies or individuals. So how Bitcoins are recreated? Again, this is just for understanding. Every 10 minutes, miners try to solve a proof of work algorithm. So as I said, it's kind of forked, and every now and then they keep the new fork comes in and the new algorithms comes in. The first one to solve the problem, and if it's a valid transaction, all the transaction is included in the last 10 minutes, and each one approves the transaction, and the first one to solve the problem gets the reward. And understand that there are only 21 million bitcoins that's available. That's one thing which you need to remember. How bitcoins are not created because you can't pay to get extra coins. They can only mine. The second thing, there is no central bank. Developers cannot add extra coins, and even miners can't mine extra or faster in response to market forces. This is something beautiful about Bitcoin. That's why you see Bitcoin's utility is growing day by day. So why you are talking of a blockchain? Because as I said, distributed ledger technology was existing, and Bitcoin was the first blockchain protocol to use distributed ledger technology, and blockchain is a byproduct of Bitcoin, and that's the reason they're using block to create a chain, and every 10 minutes on an average, and every block we have seen it attaches to the previous block, and if there is a disagreement in the valid blocks, then the block is disabled, and you can, the more chain it is, the more useful it is, and it can create interesting things. So that's how mining and blockchain are intertwined. So I'm just repeating some of the hardware for mining. You have some CPU, which is an old one. If you have FPGA, ASIC, and GPU. I'll try to show some of the examples. So CPU mining, most easiest commonly available hardware, problem associated node designed for high value calculation, and very, very astronomical. Currently, you need a lot of CPU mining machine, but it's astronomical cost. Earlier, in 2009, when it started, you can mine in your home computer. So there are some of the various CPU models, Core i7, these are some of the ones which is getting used. So what is GPU? It's more focuses on mining due to reduced instruction cost. So you have you have this AMD company, right, and NVIDIA. So basically you have a comparison and you can choose your GPU. Primarily this is more used for Bitcoin mining. And you have these models and the hash speed. So the more, Tesla K20 actually comes with 134 power 0.8 M hash per second, and you have something like GTX 590 that I have used. It comes to like 193.1. And AMD I've seen like up to 2094 transactions. That's like 69990 into 3. That's like M hash speed. This is for information. And FPGA, it's actually field programmable gate array. It comes in a blank state and it can be programmed to the user needs. So you need to understand. Sorry, there's a spelling mistake. E is missing. So it's actually according to the user needs. You have various FPGA. Now currently there is a FPGA demand in the market. And you have a lot of software. I think the best one which I have seen is like Easy Miner, Bit Miner, you have Diablo, you have CG Miner. There are some of the popular names in mining software for Bitcoin. So this is a screenshot from CG Miner. So CG Miner is actually supports Windows, Linux, and Mac, and it's actually AMD. And you have open network and some of the password and things like that I've just given here. And this is ZTX FPGA. This is some of the local that I've downloaded. GUI Miner. This is one of the software that you can use. RFC Pool. This is one of the one where you can join yourself to learn and you can make some Bitcoin money. So I'm introducing why not join a pool? This because as you see, right, you as an individual you can mine, but you need to have cost that you have to involve. So why not you join a pool? So Bitcoin, there are a lot of pools. Some of them are like Slush Pool, LGS Pool, Gash I.O, and BTC Guild. So you can join a pool, you can put your own algorithms, you can do proof of work, and you can mine a new Bitcoin. In the section 3, we've kind of seen what is mining and what are the equipments and some of the hash rates and some of the selection, and you can even join a pool.
So that's it. I hope you have a basic idea on mining. In the next session, we will dive into databases, which is mainly distributed databases. Thank you.
You need to remember how bitcoins are not created because you can't pay to get extra coins. They can only mined. And second thing, there is no central bank. Developers cannot add extra coins, and even miners can't mine extra or faster in response to market forces. This is something beautiful about Bitcoin. That's why you see Bitcoin's utility is growing day by day. So why you are talking of a blockchain? Because as I said, distributed ledger technology was existing, and Bitcoin was the first blockchain protocol to use distributed ledger technology, and blockchain is a byproduct of Bitcoin, and that's the reason they are using block to create a chain, and every 10 minutes on an average, and every block we have seen it attaches to the previous block, and if there is a disagreement in the valid blocks, then that block is disabled, and you can, the more chain it is, the more useful it is, and it can create interesting things. So that's how mining and blockchain are intertwined. So I'm just repeating some of the hardware for mining. You have some CPU, which is the old one. If you have FPGA, ASIC, and GPU, I'll try to show some of the examples. So CPU mining, most easiest commonly available hardware, problem associated node designed for high value of calculation, and very astronomical. Currently you need a lot of CPU mining machines, but it's astronomical cost. Earlier in 2009 when it started, you can mine in your home computer. So there are some of the various CPU models, Core i7 to these are some of the ones which is getting used. So what is GPU? It's more focuses on mining due to reduced instruction cost. So you have you have this AMD company, right, and Nvidia. So basically you have a comparison and you can choose your GPU. Primarily this is more used for Bitcoin mining. And you have these models and the hash speed. So the more, you don't know, Tesla K20 actually comes with 134 power 0.8 m hash per second, and you have something like GTX 590 that I have used. It comes to like 193.1, and AMD I have seen like up to 2094 transactions. That's like 69990 into 3. That's like m hash speed. This is just for information. And FPGA, it's actually field programmable gate array. It comes in a blank state and it can be programmed to the user needs. So you need to understand. Sorry, there's a spelling mistake. E is missing. So it's actually according to the user needs. You have various FPGA. And now currently there is a FPGA demand in the market. And you have lot of software. I think the best one which I have seen is like Easy Miner, Bit Miner. You have Diablo, you have CG Miner. There are some of the popular names in mining software for Bitcoin. So this is a screenshot from CG Miner. So CG Miner is actually supports Windows, Linux and Mac, and it's actually AMD, and you have open network and some of the password and things like that I have just given here. And this is ZTX FPGA. This is some of the local that I have downloaded. GUI Miner, this is one of the software that you can use. RFC Pool, this is one of the one where you can join yourself to learn and you can make some Bitcoin money. So I'm introducing why not join a pool? This because as you see, right, you as an individual you can mine, but you need to have cost that you have to involve. So why not you join a pool? So Bitcoin, there are a lot of pools. Some of them are like Slush Pool, LGS Pool, Gash I.O, and BTC Guild. So you can join a pool, you can put your own algorithms, you can do proof of work, and you can mine a new Bitcoin. In the section 3, we've kind of seen what is mining and what are the equipments and some of the hash rates and some of the selection, and you can even join a pool.
So that's it. I hope you have a basic idea on mining. In the next session, we will dive into databases, which is mainly distributed databases. Thank you. Welcome to the session of distributed databases. In this session, we will learn more about what is distributed databases, how it works, etc. So let's start this.
So we are in the module 2 and we are in the section 4, which is like we are on distributed databases because distributed ledger has some of the distributed databases as a basic concept, because this is also one of the technology that's been used in blockchain. So let's see how it actually helps blockchain. So what is distributed database? There are no data storage. All nodes contain all information and every client has equal rights. That is the most important thing of distributed database. Advantage of decentralized database because you have high security, you have reliability, you have accessibility, you have data transfer rates and it's scalable. Let's understand some of the characteristics in detail. So first question is security. Well, they do not have centralized storage, and the second thing is actually stored between the nodes of the network. If something is tampered or added or deleted, it will be reflecting across the network. And if some legal amendments or anything can be done, it will be spread among the other users throughout the network. And data will be coinciding and kind of converted in all nodes. So that means like it is protected from deliberate attacks or even someone trying to tamper the change through accidental, it kind of prevents it. So that's what I say, just say in one sentence, kind of is called it's self-sufficient and self-regulating. I'm not saying that it's highly secure, but it kind of solves some complexity of security issues. So it is also having the reliability and accessibility and data transfer. Let's understand how. Decentralized networks can actually withstand the significant pressures on the network. So actually the requests are distributed between the nodes. So the pressure doesn't fall on one computer. And the capacity of the network is so large that no centralized person can solve. Second thing is DDoS kind of attack, which is popular cyber attack. If the capacity is much larger than that of the network, so it's very difficult. That means that you need to have an expensive attack. And in a centralized model, it's very unique. But here, it's a decentralized. So distributed networks are safe. And third thing is the users are located all over the world. And in decentralized distributed network, you can choose a node and work with all the required information. So it kinds of answers some of the questions. It withstands a significant pressure and it has multiple copies, no centralization. So even somebody needs to attack, you need to build a network which is much larger than this network. And best thing is it's scalable. In a centralized model, you have a client which is connected to a server, but here only one server stores all the data. Whereas here it's like infinite. The situation in distributed servers is like it's finite, and it will be very effective till the time the number of participants. And if there is a load, it cannot exceed. Whereas in decentralized and distributed models, you don't have the problem because the load is shared between several computers. So you understand, right? In centralized model, it's client server and only one server or complementary server store the data. And so every transaction keeps coming, adding through the main computer. And there are finite resources, it can do the work. But in the distributed, it is like shared and the load is actually helping to solve the problems faster. So how can this decentralized and distributed database be applied? So why it has to be distributed and decentralized? The databases accelerate the communication between different parties in production lane. That means like you have multiple copies and you have transactions split. Let's consider the following example. In the entire life, the car passes many stages from assembly, sale, insurance, and into the utilization. At each step, a lot of documentation and reports are developed. If any clarification required, the request goes to different authorities. It takes a time, location, language, bureaucracy may become serious problems. Whereas this can be solved by decentralized one. So here, all the information about each car is stored on the network, and this data cannot be removed or changed without the participant's approval. And you can access the information you need anytime, and smart contracts facilitate the blockchain implementation. So understand this. So blockchain is actually able to scale and solve these problems. So in this section, we have seen a bit of what is distributed databases, and we are trying to understand how it fits in the decentralized distributed ledger or the decentralized ledger.
Here comes an end to this session. In the next session, we'll know about the Ethereum smart contract, and it will be interesting to know about this. Thank you. Hello, we are in the fifth submodule of Blockchain Advanced, which is called Ethereum smart contract. Let's see a bit of how smart contract can help in the financial organization. So what is a smart contract? I would have explained in the previous slide, it's actually use of software code and a blockchain to execute a legal contracts in a consensus mechanism where conditions are met. So it's simple software code to have legal contracts or any other contract between two parties where they agree to a certain conditions. So let's understand what are the universe of smart contract, where all it is applicable. So it's a legal code, it has group rules, and it can also track the device interactions. So three things: it has a legal code, it is a group rules, and it has a device interactions. And this is how it changes. Basically, you have a group, it forms a legal code, and it gets binded between the code where there are multi-parties in the system, and finally it is self-executing and it's harder to breach.
because it's very less ambiguous here. Otherwise, we have to have the regular contracts are good. It's been existing for many years. But when you compare for software code, simple line of code which is self-executable and it's harder to breach, is much easier to control. So basically, this is a kind of a complete contract which happens like it comes with a purpose, a proposition, it goes for the negotiation, then counter proposition, violation. So this is a typical mechanism which happens whether it is terminated, failed, fulfilled, etc., in the contract. So this is like again there is a proposition, then counter proposition, then valuation, then resolution, violation, inactive, active request. It keeps going on. So the first use case is in the e-voting. For example, if there's a listed company, for example, if it's listed in any of the stock exchanges, and all that you can do is just a smart contract that you can send it to the suppose there is need to be a change in the management or the board, and it requires the approval of the general body meeting or the investors. All that you just need to do is a e-voting mechanism through a smart contract where public voting is really not a concern. Then you have stock certificate, it just comes as a smart contract. This is another example. So some of the things I'm just pulling the snippets actually. Smart contracts on Wall Street. So they've already taken care, many of the Wall Street, they're trying excellently, the smart contracts. There's another smart contract called Hedgie. It actually helps commercial traders, over the counter. So there are a lot of commercial trading that happens, right, over the counter. So forwards or, with less counterparty risks. That's important. So Hedgie is just another example where it's between the commercial traders. So this is again one more smart contract where there's a spot price versus, how much he has owning in terms of shares or, any of the thing. So this is again another example of a lighthouse, So basically you have a smart contract where you can even raise money, fundraising, So these are some of the examples. Augur is one of the things where you can actually clearly understand in an early warning system for everything. A clear future, It kinds of platforms, it kinds of gives you better forecasting for any of the features like politics, commerce, technology, entertainment, and more. These are some of the snippets, or some of the use cases that's using smart contracts. So there is an urban art. Here also they are seeing where blockchain-based smart contracts are coming, even for selling art, music. So this is again, where they're trying to use blockchain with kind of using smart contracts, for music. People who can come and put their music, any prototype. Boardroom, it's used for votes. It's contractually secured, This is one example. It comes with the blockchain governance. Very interesting, Boardroom is one of the good blockchain app that you can use for voting democratically. So basically what you are seeing is, this is one of the snippets that I have taken from October 21st, where Nasdaq's Greenfield is talking about blockchain and how it is going to streamline the proxy voting processes. And there's some of the things consumables, service marketplace, energy marketplace. So basically it's it can be used in any of the places. So as I said, this module, I just covered what is smart contract and some of actual examples of smart contract, So that is very, very important. So that's all for this session. Hope you have understood whatever I had discussed. In the next session, we will get an overview about the Ethereum with the topic Introduction to Ethereum. Thank you. Hope you have understood whatever I had discussed. In the next session, we will get an overview about the Ethereum with the topic Introduction to Ethereum. Thank you. Hello and welcome to this session. As I have just said, we will discuss about Introduction to Ethereum and get a clear overview of Ethereum in this session. So we will be touching on a bit of Ethereum because smart contracts come from a platform called Ethereum. Let's understand how it is useful in the financial organization. So it is a component of blockchain technology. The Ethereum platform can be used for writing distributed applications. As I said, distributed ledger is the whole universe. Out of that, blockchain as a first use case started from Bitcoin. And the third one, it started creating decentralized applications. The Ethereum is one of the platform apart from Bitcoin which became popular, where you can write your own applications on Ethereum. And it also you can use cryptocurrency like Bitcoin. And it is useful for web, business or society. So what is Ethereum? Ethereum is a decentralized platform that runs smart contracts applications exactly as programmed without any possibility of downtime, censorship, fraud, or third party interference. So, understand this. First is a decentralized platform, it runs smart contracts. It also has applications that run exactly as any other web applications without any downtime, censorship, fraud, or third party interference. So, how is it different from Bitcoin? It's more general, Bitcoin. It's not just a currency. Here you have a node which has a virtual machine planning. It's like a computer, and the virtual machine runs smart contracts. And the users can actually call functions on the contract, which is called transactions. So this is blockchain 2.2. It started with Bitcoin, but here you can create a node which runs like a virtual machine and it runs smart contracts. And all the transaction happens on the smart contracts. The core idea was simple. The founder says something like this. The core idea was simple. A blockchain with a built-in Turing complete programming language allowing users to build any kind of applications on top. That is why Vitalik. So basically, that is what, as per the thing, and there is another counter code from Coinbase, which is one of the exchanges, crypto exchanges. There's nothing that Bitcoin can do with Ethereum cannot do. While Ethereum is less battle tested, it is moving faster, and has better developer leadership and developer mindshare because this is core towards programming language, right? It can be absorbed easily by any of the developers. So as we see, what are smart contracts? They contracts that lives on Ethereum blockchain, and Ethereum has their own address and balance, and the currency which is used in Ethereum is called Ether. So they can use send and receive transactions, and they are activated only when the transaction is happening, and they can be deactivated. The Ethereum virtual machine runs on a complete Turing language. So actually, it runs on what is called a solidity, and they have a fee per CPU step with extra for storage, and they can use the application on their local blockchain. So you need to understand contracts live on the Ethereum blockchain. They can send and receive transactions, and they also have a currency. They also have an address and balance. Then it runs on a CPU per step, and there is extra cost for the storage, and they can run this application on their local blockchain. So this is Ethereum node. You have a virtual machine which has smart contracts, and there's a transaction that hits, and whatever the transaction that hits, it gets updated on the state of the blockchain. As you know, would have seen what is state in blockchain state. It moves from S0 to S1 state or a new state. So similarly, Ethereum node also is available. So this is like a program. Ethereum programming language is there. It's called Solidity. It's like a JavaScript or a Python or a C-like language or a Lisp. So it's a combination of all four. It's a JavaScript with Python, with C and Lisp. And they're actually compiled into bytecode before being deployed into the blockchain. So it's a very useful thing. They're compiled into bytecode before being deployed into a blockchain. So Ethereum programming, you need to understand, it's called Solidity. It has Serpent, Solidity, Mutant, and LLL, which is similar to Lisp-like. So this is how a smart contract happens. For example, for a voting, anybody can vote. Transaction passes through a function called vote, and it counts on the blockchain.
So let's end this session here. Next, we will learn how blockchain enables security and we'll get an idea of blockchain security aspects. Thank you. Hello, in this session, let's discuss about the blockchain security aspects. We'll also know how blockchain enabling the security. Let's start then. So let us understand the next section, how blockchain can be enabling security, mainly information security and cyber security. So it's a virtuous cycle. You have security, it includes blockchain. Let's see how it happens. We have already seen, right? Blockchain isn't interpreted broadly like it's a tamper proof and it follows precision rules, no trusted parties, and it has confidential data only to authorized parties. So these are some of the advantages or the characteristics of blockchain. It is tamper proof, it updates, follow precision rules, it has trusted parties, and it's completely private or confidential. It's basically a new combination. As I said, how did it happen? It's a combination of peer-to-peer networking. We have seen that, communication happens through peer-to-peer. It's a distributed consensus. You don't have a centralized consensus mission. It's a replicated state mission. That means one has to happen from one state to another state happens, and then it gets replicated in the chain. Then it's programmable. You can write programming language. You can use it as a programming language to develop application. It is cryptographic.
It has cryptographic hashing for data immutability. Finally, it has digital signatures and signature for authentication. So what is this? It's a combination of all these 6-7 ideas that has come as a blockchain, which is basically the distributed ledger technology, or what we call popularly as distributed DLT. So it's peer-to-peer networking. It contains distributed consensus, replicated state machine. We did understand what is state machine and how it is different from how blockchain state machine happens. It is programmable. It has a specific domain-specific rules. It's like smart contracts as example. It has cryptographic for immutability. It has embodied with digital certificates, and it goes with signatures for authentication. And it comes with privacy and confidentiality, where you have encryption, you have multi-party computation, you don't need any knowledge proofs, and it is homomorphic encryption. So particularly related to privacy itself, you have 4 of them. So that is very, very important. So now what we need is data safety, data confidentiality, data privacy, and it also should be computable fast. So these are some of the things which is information security rules, right? So all of them is kind of covered by blockchain. Security, it is protection of both machines and resources. So it is security of protection of machines and resources, availability and reliability of networks and systems. It gives integrity of data. It has economies, global economy. Everything is protected. It's just not about single mission. You can create one ledger across the globe. So all of them are some of the integrated features that comes with blockchain. Protection of human rights, privacy. Most of them is now looking at privacy, right? We should not have like GDPR, which is introduced by EU this year. It's like basic thing of protection of rights, freedom of expression, system of government, humanity. Overall, it's kind of protection of everything that is helped by blockchain. So can we actually see like whether blockchain redefines cybersecurity? Actually, no. Blockchain may not be the solution to every problem, but existing challenges remain, new ones arise. But what we are saying is security is enhanced because you are actually deleting the bad behavior of any participant by giving one single point of trust. You have a consensus, you have a immutability, you have a single ledger, and you are solving your ledger cannot be attacked because you have multiple copies of data in each node. Processing is fast, and so like you are redefining, you're actually giving a scalable solution to the cybersecurity, so that the basic cybersecurity issues doesn't exist here using blockchain. It's called programmable trust. So it's like, when I suppose I can specify reset my password and one colleague for one bank. So this is like creating my own rules, my own stronger passwords, and my own crypto keys. That's how we can call it as a programmable trust. So this is one of the new buzzword that's kind of getting using blockchain. It's more secure, more useful. It has higher value assets. It's creating more important use cases, creating higher value assets. It's more important use cases. It has got wider adoption. It is giving economic security because there is accountability, there is transparency and trust that is spread between the economics and communication system. So it is reduced systemic risk and no more of these GFCs. You don't have a single point of trust. So it's kind of giving an economic turnaround with the accountability, transparency, trust, immutability, programmable trust, and it's actually reducing the systemic risk by redefining the whole technology landscape. That is blockchain. It's just not about assets and finance, right? It's kind of creating a identity, authentication, and reputation. So you can actually enhance your identity. So in India, we are seeing like the conglomeration of banks. They are trying to create one platform for KYC, know your customer. So it's unique. It's going to have an authentication protocol, and it's also solving the reputation problems. See, some of the things which we need to understand, just not assets and finance. It is kind of giving provenance as well. It is giving informed consent and consent for purpose. So it's like privacy is taken care here, and personal control of personal data, be it for social records, health records, or clinical trial data. It's just not about assets. Blockchain is trying to create a revolution in this entire thing. So Klee blockchain, cryptographic hashing, we have already seen it works with SHA 256. Like one hash, you give a 256 or 512 output. It's one-way function. It's impossible to find the original data. It's collision resistant, and it can't change the input without changing the output. So very, very key. And this is the key blockchain ingredient, cryptographic hashing. Please understand this. And I've given the summary. I've tried to give you the basic concepts. but this is an advanced subject. So its blockchain is tamper resistant. Each block contains a cryptographic hash of the previous block contents. We have seen this, there's an arrow diagram where it always points to the previous. It's changing, any block will be changing to all subsequent hashes. That's very good. That's one of the important things. And it's immutable and tamper proof. Why changing any block? Because as we have seen, any changes, any edits or changes in one block will kind of the whole nodes. It will change the whole block. So it completely changes the genesis. So that's how you see. If you change one previous block, it goes back to the whole thing, and it's immutable. You can't reverse it. It's very, very different, very, very difficult. So that's why we call blockchain as tamper resistance. Every block contains a cryptographic hash of each of the block's contents. Any change in one block will subsequently changes the whole hash, and it's immutable, and it is tamper proof. So blockchain also contains transaction data. It's immutable. Your information, you can't do immutability. Whether it doesn't matter, any kind of data, it's immutable. And so like right to be forgotten, blocks also contain transaction data. If something happens to you forgotten, that's okay. It's safe and lying in the blockchain. That's the biggest thing. You have the right to be forgotten as well. So either when you have something like this, you have possible solution is you can encrypt data or store cryptographic data, identifying off-chain data, like only information about you. This is one solution. Like when you have the right to be forgotten, you can actually have encrypt data or store cryptographic data, off-chain data, especially yours. Or it's just know the hash, its name. Other possible solution is there any way that somebody has deleted it? No, because it is like off-chain. It can be safely lying in some place. All that you need is identifying the data. Or somebody has kept it, It can be like, it is there in the previous block and it can be lying somewhere, These are some of the solutions. Solution 2 can be given for specialized authorized parties, But it's like what I'm saying is they will never collision resistance, and different block with the same hash. Hash will be same, but you have a different block because you are having some trusted parties, in this. Or it can be like, available as a collision resistance with some other authorized parties. These are some of the possible solutions. Absolutely what happens is when you move from one hash to another hash, you can't do the modification to subsequent blocks. So that's how you see like, in the front, pre-PVR. So basically what you are saying is it's about your data, but it's like something happens, nobody can actually modify the subsequent blocks. So what is actually, basically we are doing a comparison between two solutions, encrypt and chameleon hashes. So here you are seeing an encrypt form where hash is kept about it, and in the second solution we are talking of a chameleon hashes where we are trying to give specialized authorized parties the chance to have the data. So if you do a comparison, chameleon hashes has much better characteristics. Special cryptographic technology, chameleon required. Honest and encrypted data, you don't need a chameleon to do that. And guarantee all deleted information, you cannot guarantee anything, So basically you're trying to do an encryption hashing technology with off-chain and chameleon hashes. So it's one of the popular solutions that exists in the market. And just giving a crude example of, how we can encrypt or use chameleon hashes to answer these 4 or 5 questions, So chameleon comes with the immutability, it comes with a feature. And it's basically what we have to see is whatever hashing doesn't mean, but you have to have immutability, which is having auditability and integrity, and have an effect on subsequent transaction. Very, very important. So we have seen a comparison between encrypt as a solution and chameleon hashes, and how we need to have an immutability as a feature. And it should be limitless, it should not limit. And it also stifles innovation, So probably if you have to have encrypt or offshore off-chain, it kind of gives some limit solution stifle, whereas chameleon, it kind of goes and goes on, Remember, it's a one-way function, and if there is a real honest ones will delete information, but actually multiple copies may lie, using cryptography. And no solution can ensure dishonest participants and delete their data ahead. So nobody can guarantee, here. So here in this point, we are saying it's a one-way function. If there is a honest guy who want to delete it, we don't even know. But no solution can actually ensure dishonest participants, and they may have or may not have. So that's all. With this session, we'll end this module.
Hope you have enjoyed this module of the blockchain course. See you in the next module, which is all about Bitcoin, the first blockchain, why cryptocurrency is needed, evolution of cryptocurrencies after Bitcoin, the other altcoins, ICOs, etc. Thank you.